Welcome to Oklahoma Gardening. Before we get started today, I want to share a little tip with you because if you're like me, you're pulling out your seeds and you might find some that are a little out of date and wondering whether they're still viable or not. So a quick simple test to do is the paper towel test. You simply wet a paper towel and lay 10 seeds on it. Now we're going to fold that paper towel over those seeds so that we have good contact with them. And then we're going to place that paper towel in a Ziploc baggie. We're going to leave those in there for about 7 to 10 days, and at which time we're going to pull that out and see how many seeds have actually germinated. Now, because we use 10 seeds, it's going to be easy to calculate the percentage of germination. If we have 5 seeds that germinated or sprouted, then we know we have a 50% germination rate. On today's show, we've got an Asian pear that you absolutely have to try. Becky Carroll will show us how to grow one ourselves as we walk through the process of planting a bare root tree the right way to get started. Plus, we're digging into soil science, what's happening underground, and why it matters more than you think. And finally, we'll show you how to inoculate your own mushroom log at home and get your own fungi growing. Underwriting assistance for our program is provided by the Oklahoma Department of Agriculture, Food, and Forestry, helping to keep Oklahoma green and growing. Oklahoma Gardening is also a proud partner with Shape Your Future, a program of the Tobacco Settlement Endowment Trust. Shape Your Future provides resources for Oklahomans to make the healthy choice the easy choice. For generations, Oklahoma Gardening has been welcomed into your homes. It's a place to learn, to grow, and be inspired. It's where Oklahoma State University bridges research, education, and passion. We share one goal: to serve the gardeners who inspire us. That's what makes Oklahoma Gardening true to Oklahoma and true to gardeners. Today we're out here at the Cimarron Valley Research Station just south of Stillwater, and joining me today is Becky Carroll, who is our fruit and nut extension specialist. And Becky, you know I'm not a big fan of pears, but you tell me you got one that I'll like.
Yep, this is a different kind of pear. This is called an Asian pear.
Okay.
And so European pears, usually the ones you see in the grocery store most often, those are, they have grit cells, but these are called apple pears as well. And so
they look like an apple.
They do.
Yeah.
The shape looks like an apple, but the texture is more like an apple as well.
Okay.
Very crisp and sweet, but these are juicier than most apples you've ever eaten as well. So really hydrating, lots of fiber, really good for you. And instead of, buying them at the grocery store in a little foam package that are pretty expensive, you can grow your own.
Okay.
And they can last for several months in your refrigerator or even just in a cool, dark place.
Okay, they're kind of a specialty crop, right, at the grocery store. So this is not something you just pick out of the bin per se, right?
No, they are protected and pricey.
Okay, all right. So let's grow our own.
Okay.
And I see we've ordered in some trees here.
Yep.
Let's talk a little bit about kind of how to establish a tree and why we would be doing it this way versus a lot of times we start seeing those containerized fruit trees showing up.
These are bare root trees, and so we've got 2 different types because we need cross-pollination between 2 varieties.
On this particular one?
On pears and apples and a few other fruit trees. But these are bare root, so they are dug at the nursery. They take a big spade and they go along and they cut underneath the root system, and then they store them until they ship them.
Okay.
And so a bare root tree is usually less expensive than a container tree. They get established pretty quickly, and you can also order a smaller size tree. And that's key for getting them established and growing quickly, setting the structure properly. If you have a big, tall tree, it's hard to get that structure correct. If you're not pruning it back after planting.
Right, and we're going to talk about pruning here in a minute, but it's like you don't want to buy too much and have to cut it off, right?
And so I like to order small trees in the fall, have them shipped to me about this time of year.
And also you can be a little more particular on your cultivars that you're buying,
you can.
Right?
There's a lot more to choose from.
Okay.
And so you have a big selection And like I said, you can get a different size tree. So on pears and apples, I want at least 36 to 40 inches tall, usually on a pear tree, but like a peach, maybe only like 24 inches is good enough.
Okay.
So they're less expensive trees too. I pay attention to the price. But on this tree, we're gonna take a look at it before we plant. We're going to
and of course, let me interrupt you. We've had it in water.
Yes,
so as soon as you get it, you unpack it and put it in water, right?
Not exactly.
Okay.
If you're going to be getting it shipped to you, you want to open it up, make sure it looks good. If it's got a problem, then send it back to the nursery. But these roots will dry out and they will freeze. So you have to protect them between when you receive them and when you plant them.
Okay.
So we've had this one in water for a few hours just to get it fully hydrated again.
So how have you been storing it though? Like healing it in? Is that
you can heal them in or put them in a cooler or like we've had some in our storm shelter where it stays pretty cool.
Okay, all right.
And so so on this one, this root looks like it's been damaged. I'm gonna just prune some of these back. And anytime you prune a root, it's gonna initiate new root growth.
Okay.
So that makes it a little bit easier when you're planting. Your hole size doesn't have to be quite as big. It's just initiating new root development. So it's a good thing to go ahead and do that.
All right.
Now you don't have to cut it all the way back. I might be a little harsher than some people. Then whenever we get ready to plant it, we wanna make sure we have it at the right depth and the right depth of hole dug.
Okay, and so when we're talking about this as we have it up here, this almost looks like a stem to me, but this is not all stem. You've got some roots growing here.
It was planted at the nursery about this deep.
Okay.
So you can see a color change in this area right here, and you can start to see there's little roots that are coming off. And so this portion is the root, and this is the trunk.
Okay.
And so we want to plant it about the same depth that we had it at the nursery.
All right.
So not too deep. I'd rather have it more shallow than too deep.
Okay, and I want to acknowledge this little bend right here a little bit too. So most fruit trees are grafted, right? So this is the fruiting wood that is on the rootstock.
That's right, yep. And it's very important to know where that is, because if you get shoots coming out below this budded portion or grafted portion, you'd want to remove those because it's taking energy away from your producing part.
Okay, all right. In fact, you can still see the little, where they removed that previous wood from. So.
Sure.
Okay, so we get planting?
Let's go ahead and plant it.
All right. All right, Becky, I like digging in the sandy soil.
Yes, the sand is much easier than clay.
Do they need sandy soil, or let's talk about that?
Pears and apples can handle a heavier soil. They don't mind the clay. But we're not going to amend this hole with anything else. We're going to go back in with the native soil that came out. And so no compost, no fertilizer, no sand, nothing else, just the native soil.
All right, and we got it at that right line where it was buried at the nursery.
Yep.
And we want to make sure not to bury the grafted bud.
That's right. We want it at the right depth. That way we didn't dig our hole too deep, so it's not going to sink in that hole.
Okay.
So fertilizer, a lot of people want to fertilize immediately. We're going to let this tree, we're going to let it start to grow before we add the nutrients out. It's going to be not very much, maybe a pound, a triple 10 or triple 13, and for that first season. And you could split that application in a couple of weeks' time, but wait until it's got about 6 inches of good growth on it before you start to fertilize. I will go ahead and kind of tamp it down a little. And you don't want to get too aggressive where you're breaking off any roots or anything, but I'll kind of tamp it down. Sometimes I'll use the end of the shovel handle or something, but feet work pretty good too.
Okay. And then of course water's pretty critical, right?
Yeah, especially this time of year, we want to make sure that we're gonna get water on it to get all the air pockets out, because if there's air around those roots, it's gonna dry out and your survival won't be that great.
All right. So will we need to kind of mulch this or kind of make a tree ring for it or anything?
Depending on your soil type. This sandy soil, it would do really well with some mulch, just bark mulch. At my house where I have clay soil, I would not want to mulch very heavy or at all, because it would hold too much moisture. And so you know, you kind of have to take that in consideration.
All right, we've got a little pruning to do though first, right?
We've got our tree planted. Now we're going to come back. I like to find a bud that is facing the south.
Okay.
And on this one, right here's your bud where it was. So we're going to prune this back. And
what's the height we're looking for?
we're looking about maybe a third of the tree. We're going to come back. And so about 30 inches, 36 inches is good.
So we just want to make sure we're not getting too close to damage that bud. And eventually that's going to grow and start our new canopy.
Right. And on pears and apples, we're looking for a central leader. And so we'll select this bud to be our next leader, and then we'll prune it back to get some scaffold branches on our tree. And in about 4 or 5 years, maybe we'll have some fruit.
All right, well, we'll check back in. I think it's, how long do we get a harvest? But I think we got one right now, right?
Yeah, let's test this out here.
Okay. But usually 4 years before harvest?
Yep.
All right. I'm going to see if this is true.
All right, see if I've convinced you to like pears.
It really does taste like an apple. Not gritty or mealy at all.
Super juicy.
Thank you so much, Becky.
You're welcome.
Today I thought it would be fun to come inside one of the new labs here at Ag Hall to take a look at soil in kind of a different way. Joining me today is Mark Barbadillo, who is also a soil scientist PhD candidate. And I got to know Mark because I've been pursuing my PhD in urban soils. And Mark had this great display as a TA, and I thought it'd be fun for you guys to also see this. So Mark, today we're talking about soil's net negative charge, right?
Yep, absolutely.
So a lot of times I don't think we realize that soil has an electrical charge, but it's really fundamental and important in soil chemistry, right?
Yes.
So let's talk about what you got set up here for us.
So thanks for that, Casey. What we have here are setups mainly to see that the net charge of the soil is negative.
Okay.
Okay, the first one.
So you're going to prove it for us.
I will.
Okay,
Oh, we will,
Okay.
actually. So the first one involves dyes.
Okay.
We have 2 dyes. Purple one, which bears iron, which have ions that bears positive charge. This one has negative charge. Now, we have a soil.
Okay.
If the net charge of the soil is really negative, and if we add this positively charged dye, what will happen to the leachate?
Well, like
what do you think?
magnets, right? Positive opposites attract. Right?
Yes.
Okay.
So what will happen? Will it be clear or just remain purple?
I'm going to say it's all going to stay in there.
Well, we'll see.
Okay.
We'll see. Okay. So the first thing is, again, we have a soil. We'll make a depression.
Okay.
Okay. Make a depression.
Why is that important?
Well, just to have all the drops go through the soil instead of them going straight to the filter paper and to the funnel, now screwing our
So we know that
setup.
soil is actually filtering, not filter
Yes,
paper.
perfect. So we'll make a depression. We'll add this dye drop by drop until such time we collect a good amount of each shape.
Okay.
This usually takes time. That's why I prepared another setup.
Okay. All right. So we're going to do the same with the opposite
So
color?
we'll do the same thing for our using red dye, which bears, again, negatively charged.
So it should just go right through.
So what will happen? This one bears, if this one bears negative charge and this one has negative charge, what will happen to the leachate? Will it be clear or just the same?
It's going to be repelled, so I would say it's going to be red.
It's gonna be the same thing. So that's our hypothesis,
Right,
okay?
right.
For now. Make a depression, add this one drop by drop, making sure that the drops hits the soil, not the filter paper.
Okay.
Just like what we did in the previous one.
And you're not adding any water or anything to this.
Nope,
So it's
we're not.
really, you got to add enough drops to actually get some of it.
Yes, we're not
through.
adding any water, Casey.
Okay.
And again, this one takes time. That's why I prepared another setup for
Okay.
you.
All right. So, what
so at the end of
result?
this experiment, this is how it should look like. Look
So-
at this one. This one has the purple dye, which bears positively charged ions. And look at the leachate. It's clear.
It is clear, yeah.
So it's saying that the net charge of the soil is really negative,
So
right?
the positive dye actually stayed in that soil.
Yep, the positive ions or the cations are attracted to the soil, making the leachate appear to be clear.
And the negative dye,
This one is just like the magnet thing,
yeah.
you know? Same charge repels, opposite charge attracts.
Right.
It's just like this. That's
Okay.
why we have this still orange leachate.
all right. And so we've got another little setup here with batteries.
So this setup right here is just to complement whatever findings we got from the previous one.
Okay.
Okay, so we have a battery. Battery has a positive and negative terminal. We have 2 wires with metal clips at the end.
Yeah.
We have a slurry. This is just a soil. We've added water,
Okay.
creating a slurry. So what we're going to do is we attach this wire to this negative end of the
Okay.
battery.
Black is negative.
Yep, red is positive. This will usually take 3 minutes or 5 minutes.
Okay.
I prepared this one
okay.
about an hour ago.
Okay.
So
it's
we
been
can
setting
actually
for an hour.
check. And you do the honor.
Okay,
You
all
do
right.
the honor.
So this is the negative one
Yep.
that we've got here. We're going to pull it out. Not much. A little bit, but not
Much. That's
Yeah.
expected.
So negative would repel negative soil.
Yes,
right?
that's expected.
All right. So here is the positive. Oh my goodness.
Look at
Look
that.
at that.
There's no trick in that.
It looks like you just stuck it in a
No. That's
clod
legit.
of
That's
mud.
legit. There's no trick in that.
Okay. But it's very uniformly all along the probe there. So,
So-
definitely, this is the positive that's been attracted to the negative soil.
Yeah, perfect. So what happened is that it's just like the magnet again. This one is clearly connected to the negative end of the battery. Since this is negative and the soil has a net negative, it's not attracting much soil.
Right.
Not as compared to this one.
Okay. So I keep hearing you say net negative.
Yep.
So does that imply that there might be some positive charges
Absolutely.
in our soil?
Yep. There's some. So the soil bears either positive or negative charge. It's not that. It's just that most soil bears net negative charge.
Okay.
But again, there's still pockets of positive charge in those.
So
soil.
those might be.
That's why we
a
see
little bit.
those.
Okay. All right. So overall, though, it is a negatively charged soil that we usually are looking at, especially here in the United States.
Yes.
So why would a gardener care about this, essentially? Because we talk about fertilizing our soil, and it all comes down to a little bit of the chemistry, right?
Yep.
So tell me a little bit about how that plays into the chemistry.
So the thing is, as a gardener, we normally or we almost always add fertilizer to our soil, right?
Right.
And those fertilizers can be positively charged or negatively charged. And knowing that the soil has a charge itself, it has a net negative charge. If we add positively charged, like ammonium-containing fertilizers, for example, your ammonium, since it's positively charged, it will just stick to the soil instead of it being mobile.
Okay, so a great nitrogen source,
Yep.
NH4 plus,
Yep.
right? So a positive cation is going
Uh-huh.
to be attracted to that negative soil. But we also we hear about nitrogen runoff and stuff like
Yes.
that, right? Or leaching
Leaching.
into our groundwater.
Mm-hmm.
How does that happen?
Well, the thing is, since the soil has a net negative charge and your nitrate as well, which is a good source of nitrogen, has a negative charge, both repels.
Okay.
So it's
nitrate is negative, ammonium is positive.
Yep. So it's very mobile in the soil,
Okay.
not as compared to ammonium.
So while you think, okay, nitrogen's important for my garden, it's the form in which it's delivered that also plays into this.
Mm-hmm.
Well, Mark, thank you so much. I know this is kind of the fun science behind why we do what we do. And of course, we want to make sure that we're always being judicious when we're using fertilizer in our landscape.
Sure.
Thank you
well,
so
thank
much,
you so
Mark.
much.
Today, I'm going to be showing you guys how to inoculate logs with shiitake mushrooms. I did this as part of a new class that I created called Herbal Plant Production, but we're kind of expanding out of herbs into some other crops or things that we could sell on a small farm. So before we get to drilling the holes, we have to think about what kind of wood do we need for shiitake mushrooms. And different strains require different types of wood. Usually oak is going to be the first thing that mushroom companies will tell you will work well. But in my experience, I've also used sweet gum and tulip poplar and have found that those do well for shiitake mushrooms. Here in Oklahoma, we also have hackberry, and we're going to be experimenting with that as well to see if that does as well as sweet gums. So typically we want to use logs from a newly cut tree, and we're doing this when the tree is dormant because we want the nutrients that were in the leaves to be in the trunk of the trees for the shiitakes to be able to feed on. So we selected logs that were about 4 to 8 inches in diameter because you get a year of mushroom production for every inch in diameter. So we're gonna want to put some earplugs in before we do this because it does get a little bit loud, and then safety glasses as well. And then we're just gonna drill a few holes in our log. Typically we wanna space our holes at 4 to 6 inches apart in a diamond pattern. And apply a little bit of pressure when you're drilling, but you don't have to do it like a drill. It kind of does its own.
Working with the angle grinder was a new experience. It's a lot of hands-on experience when I'm learning from classes like these, and it makes me ready to implement them more in my career.
I do have experience with power tools. I used to weld when I was in high school. This class is covering herbs and how we grow them from seed and what we can make with them in the end. So like lotions, medicinal uses, foods, all the things. And so it's really cool to see.
So the next step in the process is to put our inoculum into the log. We're using a strain of shiitake that is called West Wind, and we're using this one because it's supposed to be a little bit more heat and drought tolerant, and because where we're located in Oklahoma, we tend to get more heat and wind. We're gonna test this out and see how it does. So we've got our inoculum transferred into a container. So this is sawdust in here. The strands of the mycelium are growing on this sawdust. And then this is what we are going to load into the log. So we have an inoculator. The tip is the same depth as our stop bit on the angle grinder. And we're just gonna put it into our mix, kind of stab it down in there. And then you're going to place it over your hole that you drilled and just punch it. There's different inoculators that you can get. You can get some that are with your thumb, or there's the dowels that we talked about before where you would just put it in the hole and tap it with a hammer. You want this to be firm because you want to have plenty of mycelium in the log so that you have good colonization. Give it a good pop.
This is something I think I would use outside of class. I do like to grow my own herbs and vegetables at home. And so getting the experience with the mushrooms will be very interesting to see if I can replicate it at home.
These hands-on experience that she has given us helps me to understand at a more deeper level.
So the next step in the process, once we've got our holes inoculated, is to cover them with wax. So we're gonna be using a food grade wax, cheese wax. We've got it melted in the crock pot, and then we're going to use a shoe polish dauber to apply it to the hole. And the reason we're doing this is because we want to hold moisture in the log and in the mycelium to prevent it from drying out. In addition to covering the holes with wax, we're also gonna cover the ends and any cuts or places where you removed a limb. Because again, we wanna make sure that we're holding in as much moisture as possible in our log. Now that we've got all the holes covered with wax, we need to talk about where we're going to put this log. So you want to select a spot that's not going to be too hot or sunny. So we're going to be putting our logs under the understory of some trees so that we can get some shade in the summertime. We also want to think about keeping these logs moist. So for us, we're going to use a drip irrigation system because we're probably going to end up with about 20 logs. But for the homeowner, you can simply water your log during a dry spell with your hose. And then you should be able to expect mushrooms within about a year.
Thank you for joining us today. If you have a question about today's episode, feel free to reach out to your local county OSU Extension office or leave us a comment on YouTube or social media. There are a lot of great horticulture activities this time of year. Be sure and consider some of these events in the weeks ahead. For the next 3 weeks, OETA will be conducting fundraising, but we will stay connected on social media, and we'll be back with another new episode on March 21st.
Okay, so when you guys get ready to go with your turn, there are gloves in the box, safety glasses, and earplugs.
To find out more information about show topics as well as recipes, videos, articles, fact sheets, and other resources, including a directory of local extension offices, be sure to visit our website at oklahomagardening.okstate.edu. Join in on Facebook and Instagram. You can find this entire show and other recent shows as well as individual segments on our Oklahoma Gardening YouTube channel. Tune in to our OK Gardening Classics YouTube channel to watch segments from previous hosts. Oklahoma Gardening is produced by the Oklahoma Cooperative Extension Service as part of the Division of Agricultural Sciences and Natural Resources at Oklahoma State University. The Botanic Garden at OSU is home to our studio gardens, and we encourage you to come visit this beautiful Stillwater gem. We would like to thank our generous underwriters, the Oklahoma Department of Agriculture, Food, and Forestry, and Shape Your Future, a program of the Tobacco Settlement Endowment Trust. Additional support is also provided by Greenleaf Nursery and the Garden Debut Plants, the Oklahoma Horticulture Society, the Tulsa Garden Club, and the Tulsa Garden Center.